Okay, we're going to do section 6, problem number 2. We're going to do this one as I asked you to do, both by disk method and by shell method, or ring method, I should say. Okay, so y equals x to the 6. That goes through 0, 0, and it goes through 1, 1, and it's very flat and then goes very steep. So that's y equals x to the 6th. I've already got a sketch of that. Y equals 1 looks like this. This intersection point is 1, 1. And in the first quadrant, which means we have to stay in here, which means if we're going to be bounded by this curve, and the quadrant, we're going to get this area. And if we rotate it around the y-axis, this is going to come up and go back there, and it's going to be the solid that has this outline. Okay, so I asked you to do both methods. So let's do the disk method. No hole in this. So if I make a slice perpendicular to the axis, this is the axis. Said y-axis is the axis. So if I make a slice that way, it's going to be make a disc, a circle thing that's got some height. Very little height. It's called d. It's in the up-down direction, so it's dy is its height. Okay, and the formula, since there's no hole in the middle, it's simply the integral from something to something of pi r squared dy, and y is going to go from 0 to 1, and the r is from the axis to the outside here. And this outside is a point on the curve x, y. This is something you've got to get used to. So then to get there, you go over x and up y, over x, and up y. So this is x, part of the coordinate of this. So our radius is x. And so our radius squared is x squared. But our integrating variable is y, so we have to replace the x with y. Well, x squared is x to the 6th is y, so x or y would be, to get rid of the 6, we take the 6th root, or take it to the 1/6 power on each side, and that cancels the powers, and we get x equals y to the 1/6. So we have pi, antiderivative or integral of 0 to 1 of y to the 1/6 squared, radius squared, dy. Well, if you have a y to a power, you multiply the powers. So we get pi, antiderivative 0 to 1, y to the 1/3 dy, and the antiderivative of y to the 1/3 would be, add 1 would be 4/3, so it would be 3/4 y to the 4/4, evaluated from 0 to 1 and times pi. If you put 1 in there, you get 3/4. You put in 0, you get nothing. So 3/4 minus 0 is 3/4 pi. Okay, wasn't too bad. Now let's try doing it with the ring method. Okay, So now in the ring method, we slice parallel to the axis. So I'll do my slice right here. And that slice would come around, up, over, and back down, and go back around here. And hopefully you're seeing a pipe here. It would go round like that, and around like that. And it's open inside. It's just got a thickness of this wall, which that thickness is in the x direction. It's dx. And it's got a height that goes from the curve to the top. And if it doesn't go clear to the x-axis, if it did, it would be 1. And if we integrate it all the way out, we'd just get the volume of a cylinder. But we want to go from here to there. So there's a little bit here. Now remember, any place on the curve, the height is y. At this x, that's the y. Here, that's the y. So this little chunk that I got to take off is y. Otherwise, the height would be 1. So the height would be a 1 minus the y height, that little bit we got to take off. So on the ring method, it's the integral, the thickness is dx, and it's 2 pi r times the height. Now, times the thickness. And just kind of emphasizing that, if I took this ring, this piece of pipe, cut the side up, this can, and laid it out, it would lay out like a rectangle with a really thin thickness. The thickness of it would be dx, like we said, thickness of the wall. It would be at the height here, which we decided was 1, the whole thing, minus this little bit of y, 1 minus y, and the length around it is the circumference of that circle, which is 2 pi r. But r is this length, or this length, or that length, which is the distance out to the point on the curve, and the point out to it is x. Y is up, well, x is out. So this is just x. So it's 2 pi x. So we have the integral 2 pi x times y, which is times h, which is 1 minus y. But we have to have it in x, so y was x to the 6th dx. And we're going to integrate that. Okay, y was x to the 6th. Remember that? So we're going to integrate, and now we're looking at x's, and x is going to go from 0 to 1. And we should get the same answer. So let's see if we do. So we got 2 pi integral from 0 to 1 of, see, if I multiply through, distribute that x, I get x minus x to the 7th dx. Antiderivative of that would be 1/2 x squared minus, add 1 to 7 is 8, 1/8 x to the 8th, evaluated from 0 to 1. If I put 1 in here, I get 2 pi 1/2 minus 1/8. And if I put in 0, I get nothing. So 1/2 minus an 8, that's 4/8 minus 8, that's 3/8 times 2 pi. So the 2 would reduce this to a 4, and I get 3/4 pi. Okay? That's number 2, done both ways.